Hi everyone, this video is a part of the chapter Wave Optics, and we are going to learn wavefront and the types of wavefronts and also Huygens Principle. In the year 1678, the Dutch physicist Christian Huygens put forward the wave theory of light. He is also called founder of wave theory. This Huygens wave theory successfully explains the phenomenon of interference of light, diffraction and polarization, and also it can verify the loss of reflection and loss of refraction. The wave theory introduces the concept of wavefront. Let us try to understand what is meant by a wavefront. When we drop a small stone on a pool of water, the waves spread out from the point of disturbance. Every point on the surface starts oscillating with time. Let us say at any instant, if we take a photograph of the surface, then we can see the circular rings on which the disturbance is maximum. So clearly all the points on such a circle are oscillating in phase. Now the locus of all particles which are vibrating in the same phase at any instant is called wavefront. So wavefront is nothing but a surface of a constant phase. Let us see once again the definition of wavefront. The locus of all those particles which are vibrating in the same phase is called wavefront. Alright. The wavefronts are of three types. The first one is spherical wavefront. So as we can see the circular rings on the surface of water, similar way when there is a point source in a medium, it emanates spherical wavefronts in the surrounding medium. The source of light is point, we get a spherical wavefront. The second one is cylindrical wavefront. When the source of light is a line as shown in the figure, then all the particles which are vibrating in the same phase are joined, then we get a cylindrical shape like this. So you can see the top view, all the particles are vibrating and which are adjacent and also at the bottom part. Right? Now the third one is plane wavefront. This wavefront is formed when the source of light is far, let us say at infinity, let's say the light from sun or moon, etc. All these particles which are vibrating in same phase are joined, then we get a plane. So this is the wavefront which is generated by the source of light which is at infinity. Huygens principle is essentially a geometrical construction which gives us the shape of the wavefront at any time. According to Huygens principle, every point on a wavefront behaves like a light source and emits secondary wavelets. And these secondary wavelets spread in all the directions with the velocity of light. This is the first principle. The envelope of wavefront of secondary wavelets gives the new position of wavefront only in the forward direction. He said the back wave direction shouldn't be considered. That's actually the drawback of Huygens principle. So only forward waves are to be considered. Now let's see from the figure, S is the main source of light from which the light is coming forward in all directions. Now let us say the particles which are vibrating in the same phase are joined by this, we call the wavefront. AB is the first wavefront which is also called as a primary wave. Right? Now according to Huygens principle, every point on that AB acts like a source of secondary wave from which again the spherical wavefronts are started emanating. You can see there, and all these spherical wavefronts are joined by a tangent, you get a secondary wave CD. Right? This is how the wave advances into the medium indefinitely. Now let's see how to draw the wavefront of any source of light. First consider a point source of light. Yes. From this point source of light we have already seen spherical wavefronts are drawn. Let us take a compass and draw the sphere. A part of a sphere I am drawing, not complete sphere. So this is a part of a spherical wavefront. So this is the primary wave. So according to Huygens principle, every point on this primary wave acts like a secondary source. So let us take a few points. The first point is at here, and second here, and third here, and fourth here. So these 4 points, let us assume these are the sources of secondary wave. Now all these sources of light again emanate spherical wavefront. Let us draw the spherical wavefront in the forward direction with the help of a compass again. So by joining all these with the help of a tangent, we will get a secondary wave. This is how the secondary wave is drawn. Like this, it continues to spread in the medium indefinitely. Now let us consider the speed of the light in this medium is v. It advances in the time t. Then the distance drawn here is equal to the radius. The radius is equal to the velocity of the light in the medium into time traveled. Let us say tau is the time travel from here to here. So how do we draw a sphere? We take a radius which is equal to v into tau, and with the help of the compass we draw the sphere of radius v tau in order to get the secondary wavelet. Now let us assume when we move away from the source indefinitely to a long distance, then the curve, the radius increases to a large distance and the wavefront becomes plane at a particular point. Let us say the spherical wavefront has become plane wavefront, or like a line, a plane wavefront at here. So again, on this plane wavefront, every point acts like a source of secondary wave. We proceed the same thing. Now we take the radius which is equal to v tau, and we'll complete drawing the spheres from the source, right? And now by joining all these secondary wavelets, we will get a secondary wave. This is how we draw for a plane wave. Let's see some examples. First one, what is the shape of the wavefront when light emerges out of a convex lens when a point source is placed at the focus? So this is a convex lens and a point object is placed at the focus at here. We know when the object is placed at the focus, image forms at infinity. So let us first draw the incident light rays from here to convex lens. And after coming out of the convex lens, the light ray would travel parallel to the principal axis like this. So they are the refracted light rays, or emergent light rays rather say. So these are parallel, right? So we have drawn the light rays but not the wavefronts. So let us first draw the wavefront at here. Very simple way of drawing wavefront is, we have to draw a surface which is perpendicular to the light ray. See here, what is the surface that is perpendicular to these parallel light rays? Obviously a vertical line. So vertical line is always perpendicular to it. That means a plane wavefront we will draw. So the answer will be the plane wavefront, because they have asked only the emergent light rays, right, from the convex lens. So answer would be the plane wavefront. Another type of question, let us say a convex lens, a plane wavefront incidents normally on a convex lens. What is the shape of the refracted wavefront is the question. So they have given us the plane wavefront incidents normally. So wavefront they have given, not incident rays, wavefronts. So when we have wavefronts, we can draw incident rays, right? As they are mutually perpendicular, incident rays would be like this, which are perpendicular to the wavefront. So these are perpendicular. So from this we understood the light rays are parallel to the principal axis. When they are parallel to the principal axis, they pass through the focus. So the light rays pass through the focus after refracting through the convex lens. Now we need to draw the wavefront for these waves, emergent or emitted wavefronts is the question. So let us try plane. When we assume plane, it is not perpendicular. When you assume like this, it is not perpendicular. But let us try this shape, which is converging shape. Then every point it is perpendicular, right? So this would be the correct answer. So we can say the spherical convergent. The spherical convergent is the shape of the wavefront that is coming out of the convex lens when plane wavefront incidents on the convex lens.